Hi everyone, in this segment we are going to be doing an overview on certain definitions that are very important to you understanding acid-base chemistry. We are going to start with the Bronsted-Lowery definitions. And when you think about a classic proton transfer reaction, it's actually advantageous to think about the Bronsted-Lowery definitions. An acid is defined as a proton donor. It gives off a proton to a base. A base is a proton acceptor. It takes a proton from an acid. So let's put this into action. Let's say this is our reference molecule. If this molecule were to act as an acid, it would be a proton donor. So you might have a base, let's say you had CH3 minus. The base would take off the proton. Thus, this molecule has acted as an acid, giving it off. But remember, we are drawing our arrows from base to our acidic hydrogen. And I know that's a little funky at first, but this molecule is acting as an acid. It is a proton donor, and it is donating it to the CH3 minus, okay? Now, let's take the other perspective. What if this molecule were to act as a base, okay? It would be a proton acceptor. So you might have hydrochloric acid, and for this molecule to act as a base, it would share its electron density, this lone pair, with the proton, and it would become NH4+. In that context, we are showing NH3 acting as a base. It is a proton acceptor taking on that extra proton, okay? So again, I very much encourage you to think about the Bronsted-Lowery definitions if you are legitimately just looking at a proton transfer reaction. Now, we also have the Lewis definitions. And the Lewis definitions you will use more later in the course when we talk about other types of reactions, like substitutions or eliminations or electrophilic additions. These are all various types of reaction mechanisms, just like a proton transfer is a reaction mechanism. And later we'll think more about Lewis acids as being species that accept a share in electron density. They are also called electrophiles, okay? A Lewis base is a species that donates a share in electron density, also called a nucleophile, okay? So the Lewis definitions are more broad and they deal with electron density. You will use those later in organic chemistry to apply this idea of electron flow to any reaction. In the context of acid-base, a proton transfer, I think you should use the Bronsted-Lowery definition so that you can track what species is giving off the proton. Well, that's a Bronsted-Lowery acid. What species is accepting the proton? Well, that is a Bronsted-Lowery base. And remember, we are drawing our arrow from base to acidic hydrogen. All right, so that's really important, really important. We will come back in the next video segment and talk about conjugate acid-base pairs because it's also very important for you to have those definitions down.